Welcome back to Applied Physics Lecture Series, Unit 3 Optoelectronics, Lecture 6. Pin detector, its structure, composition, and characteristics. So, to know the full details and operation and characteristics of pin photodetectors, first of all, you have to know few concepts. So, out of those, the first one is internal photoelectric effect. Already we know what is meant by photoelectric effect. When light source of suitable frequency or wavelength is incident on a metallic plate, then the metal is capable of producing electrons. This is the definition of normal photoelectric effect. But here you have to know what is internal photoelectric effect. This is also very similar to the concept of photoelectric effect. When light is incident on an intrinsic semiconductor, electrons are excited from valence band to the conduction band, and this leads to generation of electron and hole pair. Thus, an increase in the charge carrier concentration occurs in the semiconductor, and this effect is called as internal photoelectric effect. That means when light of suitable frequency or wavelength is allowed to incident on an intrinsic semiconductor, so such a light will produce optical energy. Such optical energy will be used to break the covalent bonds. As a result, electrons are excited to the conduction band by leaving a hole in the valence band. In this way, electron hole pairs are produced. That means charge carrier concentration will be increased. This is known as internal photoelectric effect. And second concept we have to know is what is photoconductive effect. So conductive effect is nothing but an increase in the free charge carriers leads to increase in the conductivity of a semiconductor. You know very well, more number of charge carriers are present, more mobility takes place very easily. That means the quantity of mobility is very high. As a result, the conductivity of the material is very high. Here also happens the same thing. So due to the internal photoelectric effect, we are increasing the more and more number of charge carriers. As a result, the charge carriers increased, the conductivity of the material is also increased. So the light induced to increase the electrical conductivity is called as photoconductive effect, or simply it is called as photoconductivity. Then you have to know what are photodetectors. As the name indicates, detectors, they will detect the light and they will convert the light into electrical energy. This is the simplest way of telling what are photodetectors. So in fact, actually we want to know the concept behind the operation of photodetectors. First of all, you have to know the exact definition. The devices that absorb optical energy and convert such optical energy into electrical energy. So such devices are called as photodetectors. The operation of photoelectric detectors is based on internal photoelectric effect. So whatever it may be the type of a photodetector, it will be based on internal photoelectric effect. So that's why we discussed internal photoelectric effect initially. It is again a PN junction diode, but here we have to operate that PN junction diode under reverse biased condition. When a photon is incident on the junction, an electron hole pair may be generated in the depletion region. The electric field due to the immobile ions in the depletion region will separate such electron hole pairs which are generated initially. Then the charge separation in photodetectors may be used in two ways. One is in the photoconductive mode and second one is in the photovoltaic mode. So what is this photoconductive mode? The device which is reverse biased is left on short circuit externally. The diode is reverse biased and dark current flows. The reverse voltage application will increase the depletion layer width. So these are the few important points related to the photoconductive mode. Here you have to know what is meant by dark current. Already I mentioned in the previous lectures, dark current is nothing but current which is flown in the PN junction diode due to the minority charge carriers. Then what is this photovoltaic mode? If the diode is left an open circuit, an externally measurable voltage appears between the P and N regions. Now this diode is not biased and hence dark current does not flow. This mode of operation is usually used in solar cells. Then if you consider the types of photodetectors, usually photodetectors are divided into two categories. One is a pin photodetector and second one is avalanche photodetector. So what is this pin photodetector? So already you know what is meant by photodetector, and behind this photodetector pin is there. What is this pin? P is nothing but P-type semiconductor, I is nothing but intrinsic semiconductor, and N is nothing but N-type semiconductor. If you know the circuit diagram and operation of the photodetector, pin photodetector in this diagram, the high electric field present in the depletion region causes photo-generated carriers to separate and to be collected across the reverse bias junction. This gives rise to a current flow in the external circuit known as photocurrent. That means simply we are conducting light energy into current. That means electrical energy. So it is a device that consists of P region, N region, which is separated by intrinsic region, whereas this intrinsic region is lightly doped. The entire intrinsic region will act as a depletion region here. You know, in between P-type semiconductor, N-type semiconductor, at the junction we are having a depletion region. Now the role of depletion region will take care by the intrinsic semiconductor. The PIN structure of the photodiode enables to increase the width of the depletion region to a value which is greater than the PN junction. The pin photodiode is always operate in the reverse bias condition. When a photon having energy greater than or equal to band gap energy is incident on the depletion region, here the depletion region is intrinsic semiconductor, then electron hole pairs are generated. The high electric field present in the depletion region causes the electron hole pair generated by the photon to separate and be collected across the reverse bias junction. This gives rise to a current flow in the external circuit. As the depletion region is wide, most of the incident photons are absorbed in the region and efficiency of the device is very, very high. Dark current is small. Dark currents are the currents generated by the minority charge carriers when no photons are incident on the material. Then what are the important characteristics of a pin photodetector? If we consider the VI characteristics, so voltage current characteristics or volt amp characteristics. So first one is photodiode operates only in the reverse bias mode. The photocurrent is nearly independent of reverse bias voltage which is applied. For zero luminescence, the photocurrent is almost zero, but a small value of dark current is present. As optical power rises to photocurrent, or as optical power rises, the photocurrent also rises linearly. And this is the IV characteristics of a pin photodetector. So observe here, reverse voltage, it is operated in the reverse bias condition, reverse voltage, and gradually it is decreasing and almost independent of current. And another important characteristic of a pin photodetector is quantum efficiency. The quantum efficiency eta is the sum of electron hole pairs generated per instant photon of energy h nu and is given by, so eta is equals to number of electron hole pairs generated to the number of instant photons. And if we consider another characteristics, responsivity, so it specifies the photocurrent generated per unit optical power. Thanks for watching.